Hello everyone, welcome to engineering mechanics tutorials. So in this video we are going to discuss how to find the center of gravity of solids. So up to the previous videos we have discussed how to find out the center of gravity for the plane figures. So in this video I will tell you how to find the center of gravity for solid bodies. Okay, so finding the center of gravity for solid parts. Here for plane figures the center of gravity is determined by the area methods already we know. Okay, by using the area methods we have or we can determine the center of gravity for the plane figures. So the area method consists of the formulas like a1x1 plus a2x2 plus a3x3 by a1 plus a2 plus a3 based upon the number of individual parts we are going to consider for finding the center of gravity of whole area, whole plane figure. Similarly, y also the formula we have used for finding the x and y coordinates for the center of gravity of plane figures by using this area method. Okay, and here in the same way we can find the center of gravity of solid parts by taking the volumes in place of areas. Okay, the simple modification of this formula we can find the center of gravity of the solid bodies, like in place of areas we need to consider the volumes of those solid bodies. Okay, by knowing the volumes we can find out the center of gravity of those solid parts. Okay, now for plane figures we have considered the area, for solid parts we need to consider the volume. So in place of areas, when you take the volumes, automatically we can get the center of gravity position for the solid body. Okay, the formulas we can take as x bar is equal to v1 x1 plus v2 x2 plus v3 x3 by v1 plus v2 plus v3 based upon the number of solid parts we can divide into convenient shapes. Okay, similarly y component also can be written as v1 y1 plus v2 y2 plus v3 y3 by v1 plus v2 plus v3. So by knowing the volumes of each and every individual part of the solid body we can find the center of gravity of whole solid body. Okay, and this above formula is suitable for the bodies which are made up of same material. Okay, that means here assume this solid body, this is a solid body which is a combination of cone and the cylinder. Okay, so here when these two parts of the solid body are made up of the same material we can use this same formula. Okay now, so when the part is made up of the same material we need to consider the volume in place of the areas for finding the center of gravity position. And next, if the body is consisting of two different materials with two different shapes, already it is having two different shapes. If we assume if we have the body with two different materials with two different shapes, we should consider the weights in place of the volume. Okay, in place of the volumes we need to consider the weight of each and every individual part we are going to consider for our convenient. Okay, the weight we need to consider in place of the volumes. Okay now, so why we need to consider means because of the density varies from the material to material. So due to the variation in the density, the center of gravity location varies. Okay, so based upon that, in place of the volume we need to consider the weight of the individual shapes of the solid body for finding the center of gravity. So here assume this is the body which is having a cone of different material and a cylinder of different material. So automatically we need to consider the weight in this case. So the weight formula again in terms of weight we can write it as w1x1 plus w2x2 plus w3x3 by w1 plus w2 plus w3 based upon the number of parts we can consider. Okay, here 2 only, so suffix up to 2 will be getting the formula. So similarly y component also we can write the equation in terms of the weight and the center of gravity distance of each and every individual part we can consider. Okay now, so here the weight can be determined. So how we can find out the weight? So we are saying the weight and the volume also we can find out based upon the standard formulas we are having for each and every solid shape. But for those solid shapes, how can we find out the weight means? Already we know that the weight formula is mass into gravitational acceleration. Okay, so this equation we need to modify. How can we modify means from density? But from density the formula we can write it as rho is equal to m by v, that is mass by volume. So the volume can be written, sorry, mass can be written as density into volume. So substitute this density into volume which is equal to mass in this weight equation. So that is rho into volume 1 into gravitational acceleration we can write. And here the g is common in each and every weight of the individual part. In W1 we will be getting G constant, in W2 we will be getting G constant, and W3 also we will be getting G constant. In the denominator also we will be getting the G as common. So by taking the G common, we can neglect the G term. So while finding the weight term for finding the center of gravity of the solid body, we can take directly weight is equal to density into volume of that particular shape of the whole body. Okay, so like this we can find the weight. So by finding the weight, we can find out the center of gravity. So like that we have to find the center of gravity. So here I would like to give formulas for the volumes of basic shapes. So first thing is, for a right circular cylindrical shape, the volume formula is pi r square h. For cone is 1 by 3 pi r square h. So if you know the volume, we can find out easily either weight, or if it is of same material, only we have to use the volume for finding the center of gravity of that solid body. And don't bother about the density is constant for each and every material, so that density value will be given in the problem. So by knowing the density by volume, we can find out the weight. If the body is made up of same material, we need to consider only the volume. So for that I'm giving certain standard shapes with formulas. And next shape is hemisphere, which is having the volume of 2 pi by 3 r cube. Okay, these are the three basic shapes in the engineering mechanics we face while finding the center of gravity for the solid bodies, which is the combination of these three parts. Okay, so I hope you understand how to find out the center of gravity for the solid parts. And if you have still any doubts, please feel free to give a comment to my video. And uh, if you have not still subscribed to my channel, please subscribe to my channel and share my videos with your friends, and encourage my channel. And once again, thanks for watching my video. Thank you all.